In this section, we will be writing equations of lines. We will focus on working with the slope-intercept form to write our equations. Our author and other instructors may include the point-slope formula in their discussion to write equations of lines. So you need to check with your instructor to see if they insist on a particular method. Otherwise, it won't matter the process, since we'll all end up with the same equation. Here's the slope-intercept form. If the equation is not a special case, we will work with y equals mx plus b, looking for the slope and the y-intercept. Once this information is found, they're substituted into the equation for the equation of the line. This one is easy, since we are given the slope and the y-intercept, and all we need to do is substitute this information in. So here we go. Here's the result. Before we go on further with our discussion on writing equations, let's switch to graphing, where we use the slope and the y-intercept to construct the graph. We can use any point on the line. For less work on our part, let's start at the y-intercept. From the y-intercept, we move according to the slope. The rise is 4, the run is 7. From the y-intercept, we move up 4 and then to the right 7. You could move 4 down and 7 left if you like. You'll get the same result. Connect up the y-intercept with where you finished for the graph of your line. Here we will start at 6 and then move according to the slope of -2. Since this slope is an integer, we will need to write -2 over 1. Again, we have one of two options in moving according to the slope. Just make sure in the end that your line has negative slope. Connecting the 2 points for your graph. Let's go back to writing equations of lines. Here we are given the slope, and once we find the y-intercept, we can write the equation of this line. In writing equations of lines, ask yourself if it's a special case before you get too busy with the process. Due to the slope not 0 or undefined, this is not a special case, and therefore it can be modeled by y equals mx plus b. Since we're given the slope, we are now on step 3. Substitute m and a point into y equals mx plus b. This leaves b as the only unknown. Solve for b, and we have then all the information we need to write the equation of line. And here is the substitution. We find the y-intercept is 11. Here's the equation of a line. To check, substitute the point 2, -1 into the equation. If you get the same number on either side, and if -6 is in place of m, then we have the correct equation. Always check. It's an easy check. Since x's and y's are different, this is not a special case, and therefore can be modeled by y equals mx plus b. Our first objective is to find the slope. Once we find the slope, the process is similar to what we did for the last problem. Stacking our points to avoid potential errors with using the formula, we find the slope to be -4. With the slope and either of the 2 points, substitute into y equals mx plus b to find b. Check both points by substituting in, and again, if you get same number on either side, no doubt you have the correct equation. This is a special case. If it's a vertical line, it will cross only the x-axis, and therefore the equation will be x equals the x-coordinate of this ordered pair. If necessary, draw the sketch of the situation to verify your result. This case is parallel to y equals 5. This line would cross the y-axis and never the x-axis. Therefore, the equation of the line will be y equals the y-coordinate of this ordered pair. Again, you can sketch to verify your answer. Here's an application where we are asked to write the equation of the line. Generally, we end up working with 2 points to write the equation of the line. Let's first get ourselves organized by pulling information from the problem. Make sure to pay attention to the meaning behind your 2 variables. In 1995, the value was $10,500, and in the year 2000, the value was $5,500. The earlier of the two mentioned years is 1995. Therefore, we will define X to be the number of years past 1995. If one of your variables is time, this will be the independent variable or the X variable. Assume that every time. With X equal to 0 for the first point, that makes the 10,500 the y-intercept. Recall the y-intercept always has an x coordinate of 0. We only need to find the slope to write the equation of this line. So, using the formula, we have found the value then of this automobile decreasing in value of $1,000 every year. Last, we put all this information into y equals mx plus b.